Welcome to my discussion for this week. Today, I'll be covering what some of the common tasks are for machine learning, what clustering is, as well as what the k-means algorithm available in the scikit-learn library is. Let's get started. To begin, let's cover what a clustering algorithm is. According to Stephanie Mullen in her 2021 book, Hands-on Data Analysis with Pandas, a Python data science handbook for data collection, wrangling, analysis, and visualization. When discussing the topic of machine learning, there are typically a few common tasks that need to be accomplished. Mullen expounds that these tasks are classification, regression, and clustering. According to Mullen, clustering is where we attempt to assign our data into groups with the goal of having well-defined groups with members close together and with each group distinct from the other groups. One example of clustering would be if you're given a bunch of data on produce. You might want to attempt to cluster this data into groups such as vegetables and fruits based on some of the data from the produce. An alternate scenario would be where you might not know what is common between these produce items, and you want to see these data points grouped by proximity. And then later you can assign some labels to these clusters. This would be a more common example of clustering. Now that we know what clustering is, let's take a look at one method that we have to perform clustering. According to Jake Vanderplas's 2024 article, In-Depth K-Means Clustering. K-Means clustering is one of the many algorithms for performing clustering that is available in the scikit-learn library, as well as one of the simplest. According to Vanderplas, K-Means searches your data for a set number of clusters, which you pass in to the method call when you call it. He continues to say that each cluster has a center, which is the arithmetic mean of all points belonging to the cluster. Additionally, he states that each point is closer to its own cluster center than it is to other cluster centers, which is one of the defining features of this algorithm. According to Vanderplas, k-means functions by using the expectation maximization algorithm, which is apparently common in data science. According to him, it's a basic algorithm that involves guessing some centers for the clusters initially, and then, until the clusters have converged, assign points to the nearest cluster, then set the cluster centers to the means of their own cluster. Repeating this process until these points have converged results in well-defined clusters with a relatively easy-to-follow process. Unfortunately, as Vanderplas points out that this method, while quick and easy to understand, the expectation maximization algorithm does have flaws and will not always result in optimal cluster centers. According to Vanderplas, the k-means algorithm is limited by a few things. For one, you must manually define the number of clusters that are found using this algorithm. According to Mullen, you can use the elbow point method to figure out an appropriate number of clusters. However, this may not be ideal for your use case. Another limitation that Vanderplas pointed out that I briefly mentioned is that cluster centers are not optimal. There may be better cluster centers that this method will not find. Finally, Vanderplas also points out that the k-means algorithm is limited to linear cluster boundaries. If clusters have complicated geometries, this method will not be able to detect that. Therefore, this just reinforces the importance of visualizing and understanding your data before you begin any modeling with your data. In conclusion, today we've covered what the basic tasks of machine learning are: classification, clustering, and regression. The basics of what clustering is, as well as how to use the k-means algorithm for clustering and how it functions. I hope you enjoyed my discussion, and thank you for listening.